All right, so today we're talking about logs. This is 8.1, day one. A couple of you talking in the back? It's not okay. All right, so we are going to be taking logs and exponentials. And I think the best way is to start with an exponential, not a log, because that looks really confusing and very hard to relate to. So instead, I'm going to start with something that you can all relate to. 5 to the second is 25, right? That's a no-brainer. But 5 to the what would be 23. Ooh, doesn't work out nice. Well, first thing I want you to do is think about, without logs, what would you do? Imagine for a moment this was an ACT question. Picture yourself, you're on the ACT. Let's make it just like the ACT, except you're not going to put away your iPads because most of you are writing on the iPads, okay? But you would have your graphing calculator allowed. Okay, everybody grab your graphing calculator, get that out. Try to solve this problem. You can use a calculator if you want. Don't say the answer, solve it, and turn it my way once you've got it. Don't cheat and use logs, even though that's what I'm going to teach you later. Pause for a second while you give that a shot. Here we go. If you knew enough to graph both sides and see where you cross, you are way smarter than the average bear. That's a line from Yogi Bear. Y equals 23. Hits it right about there. I could have told you it's 1 point something. You get how it's not quite 2? Because if it was 2, this would be 25, not 23. So it's a little less than 2, like 1.9-ish, and then you actually figured it out. What did you get, sir, in the front row? 1.948-ish. Okay, raise your hand if you got the same thing. All right, and that's that 4 or 5 people that figured that out. Good. All I have to do is graph both sides, see where they cross. Now, this is kind of good because it shows you what an exponential looks like. That red line there, that's what an exponential graph looks like. You guys all know exponential growth, right? It just grows, grows, grows really fast. That's kind of what it looks like. Now, that's different than a log. Aren't we supposed to be talking about logs? Yes, I just wanted to show you that this isn't the only way to solve it, but logs is one of the best ways to solve it. So, how do I solve this with logs? You rewrite it as a log. This is the number one most important thing. Would you please try a few of these with me? We're going to go back and forth between this form and log form. First step is go log. Of course, if you're going to write it as a log, you need the word log. Write that on your screen. Then we need a base number because logs have this little lower down number down here that's its base. Okay, and if we don't show any base, it means base 10. But we're going to use a base. What is the base for this problem? 5. Here's how you can tell. That's a base. See? It's the base. It's the only number in the red equation that's written as a base. So, log base 5. Then you got to jump to the other side of the equation. Jump over here and you say 23. And you jump back and you say x. Notice it jumps back and forth. And it will when you're going the other way too. It'll jump back and forth. Okay, so why is this any better? Because this one is solved for x. It says x equals that. That's a good thing. It's solved. Second thing that's good about it is that you can put it in a calculator. Although most of you can't put it in directly. No, I shouldn't say that. Actually, I think more than half the class has the ability to, but I'm still going to teach you the way that works for every calculator. Log 23 divide by log 5. Go ahead and do that, and that'll get you that same 1.9 answer that you got before. Type it in right now. I'm going to pause for a second while I do. All right, when you're typing it in, notice your calculator just says log. It doesn't say what base. Therefore, what base is it? 10. So your calculator can only do base 10. So when you're typing in log 23, do you get your really, well, I was saying log base 10 of 23 and log base 10 of 5? What you did there is called a base change. By setting it up as a divide, I like to think of it as a line going like right through here, and I go log 23 over log 5. It's totally not mathematical. It's just a way to remember that the 23 goes in first. All right. So anyway, log base 10 of 23. Sorry, having a nightmare video today. I had to start 3 times before. There we go. Good. All right, now this one, when it's done, it has a parenthesis. For Pete's sakes. Stop with the updates. It has a parenthesis right there, right, when you typed it in. And then it has a parenthesis right there. And then it should have given you the same answer as we did with the graph both sides. See where they cross. 1 point, what was it? 95-ish? Okay. That's what a log is good for. It can solve exponent problems. It can do a lot more than that, but that's like the main reason you need it. Because when you have something like this, 7 to the something equals 8. I don't know, 7 to the something. 7 to the 1 was 7. 7 to the 1 point something. Well, exactly what? Would you please rewrite this as a log? Because right now it's not a log. I'm going to pause while you try that. Okay, did you say log base 7 of 8 equals x? That's rewriting it as a log. Raise your hand if you had that right. Okay, good. So now we need to change this into the actual decimal. Log 8 divided by log 7. 1 point, I'm guessing it's like 1.05 or something like that. 1.06. All right. And you just knew it was going to be a really small amount, bigger than 1. So, all right. So, how about the other way? If it starts as log base 2 of x equals 3, rewrite that as an exponent problem. The number one thing you need to know about logs is how to rewrite them. And if it doesn't have a log, you make it a log. If it starts as a log, you make it into an exponent problem. GT, what'd you say? Good. Why is it good? Why is it better than the black one? Because you can solve it. It is solved for x. In fact, if you just make that into, what'd you say? 8 is correct. So it's done. This one isn't just so easy to look at and say, oh, the answer's 8. Now that you know, you could put it in here and go, 2 to the 8th. No, it's not like 2 to the 8th. But it would be like this. That 8, would you agree it could be written as 2 to the 3rd? Does that ring a bell from last year? If the bases are the same, the answer is in the exponent. All right, that's your next step, is to start recognizing some of them. I get, when you see this, it's really obvious, and I hope it is, that this one's going to be an easy one. And if you don't know it in your head, you could say, okay, whenever you have one that doesn't have a variable, you could put equals x, and you could do a rewrite. 3 to the x equals 3, and then you think about it for a while, and you go, oh, yeah, x has got to be 1. Or you could think of it this way. It's going to be log 3 over log 3, and if it's the same thing on the top and the bottom, it's got to be equal to 1, right? That also makes sense? Okay, so it's 1. Well, here's a rule. If the bases are the same, the answer is whatever the exponent is. What is the exponent right there? It's a 1. If this had been a 2 there, the answer would be 2. Because it'd be 3 to the x equals 3 to the 2nd. And then, obviously, if the base is the same, that has to equal that. All right, so do you catch this pattern? If I have log base 3 of 9, that could really be written differently so that you could just see the answer right away. I know you could rewrite this into a big equation, but you don't have to. I know the answer. Do you know the answer yet? What is it? It's 2, because the 9 is really what? 3 squared. And once you got that, that's the answer. Okay, log base 3 of 27. 3. Because why? Because 27 is really 3 to the third. And then whatever, if these are the same, the answer is there. Okay, about this one. Log base 5 of 125. I hear 5 and I hear 3 and I hear 1/3. 3. Because 125 is really 5 to the third. So that are equal, that's the answer. Okay, here's a more obscure one. Nope, nope. That's the answer. 3. As the base is the same, the answer's right there. Okay, here's another pattern that I don't know if you remember or not. Three to the power of log base 3 of 2. Is that a base? Is that a base? If the bases are the same, I'm not going to say the answer is the exponent because that implies this is an exponent on that. But what I'm going to say is that if the bases are the same, then good things happen. In this case, the base is the same, so the good thing is that that's just the answer. Now, I can prove that, and in honors pre-calc, your question wouldn't be as simple as, what is x? Or, like, what is the answer to this question? It wouldn't just be, oh, the answer is 2. That'd be too easy. But we could say, prove it. How would you prove it? Remember me saying if it doesn't have a variable, you could set it equal to x. Do that. Everybody write this out. I'm going to show you how you could prove that the answer was 2. Now here's the part that requires your brain to stretch a little bit. That on the board, that's not a log. If it was a log, it would start with the word log. This is an exponential equation because it's got a base, and this is the power that's on that. It's not a log. It has a log in it, but it is not a log. So therefore, I can write it as a log. Remember me saying the most important thing is to be able to go back and forth? This one even looks like it's a log, but it's not a log. I'm going to write it as a log. So I start with the word log. And then I'd ask myself, what should the base be? Self. And what is it? 3. Log base 3. And you remember you have to jump around? Of x. And then jump back. That whole thing. Log base 3 of 2. And I just want you to look at that for a moment and see what you've got there. Trying to prove that the answer is 2. Do you get logically now why x has to be 2? Log base 3 of something has to equal log base 3 of 2. Do you get x would have to be 2 to make that work? All right. Yes? No, sometimes the problems require you to write it as an exponential. So for instance, your problem might look like this, and you asked me, do you always put it in a log? Nope, because sometimes they're like this. That's already got a log, and I don't want a log anymore. So sometimes you have to make it into a log. Sometimes you have to start with a log and get it out of log form. Like this one. Everybody get that one out of log form. What you write shouldn't have a log anymore. And I bet you'll know the answer, except that it's really big. But I think it's actually doable in your head. If I rewrite this, should have said 2 to the, or jump around, 5 equals x. And I actually happen to know that one. What is 2 to the 5th? 32. So x equals 32. All right, some more things we got to know about logs. Number 1. What's different between this and this? A lot. A lot is different. One of them is in a log and one of them is not. An exponential, do you remember graphing it a little bit ago and it looked like that? Logs look like that. And exponentials and logs are the inverse of each other. Hold on, I just threw in a math word from last quarter. Do you remember when they flip over the line y equals x? It's a reflection across there. Points like 3 comma 27 turn into what point on this guy? 27 comma 3. Remember how the x and y flip around? That's what these are. These are inverses of each other. So they're related, but they're not the same as each other. Of course, they're inverses of each other. I did not draw that as a perfect reflection, but again, points like, let's say way down here, it's like negative 10 comma 0.9 or something. Then I'd have the point 0.9 comma negative 10, which would be like way down there. So it is reflecting properly. Maybe not perfectly. Okay, so that's one thing that's important, is the logs and exponents are inverses of each other. Another is to be able to rewrite them back and forth. So if I give you this, can you write it a different way? Sure you can. Would you please use your calculator? Not use calculator. Just use your iPad and rewrite this thing into log form. Here's the thing. If it doesn't have a log, you make it a log. If it already has a log, 9 times out of 10, except for that one weird one I showed you, if it already has a log, you write it without the log. You just kind of like go back and forth between the two. All right, so this guy is log base 3 of 12 equals x. I don't have that one memorized, do you? No. But could you find it? Yeah. Now that it's solved this way, you can just type it in the calculator. You type in what? Log base 3 of 12. Most of you can't do that on your calculator. What could you do? Log 12 over log 3. And that changes it from base 3 to what base does this guy have, even though I don't see any bases? Base 10. That brings up the point. How many different bases are there? There's an infinite number of bases, but there's only 2 that are pretty common. Log, if I write log 5 and there's nothing written for a base, that's the common log, and that means base 10. And one of the best tips I have for you is whenever there isn't a base, then that's the key to the question. Okay, so it doesn't have a base, it's trying to trick you into thinking that there is no base or that you'll be stuck because you can't rewrite it. Like, how am I supposed to rewrite this? I can't rewrite that. Yeah, you can. You just got to know what the base is. What's the base? 10. So we go 10 to the x equals 5. That's rewriting it. Do you get how if you didn't have the 10 there, it'd be kind of confusing how to rewrite it? So if there is no base, then that's the key to the question. All right, so when else is there no base? When they say ln. You remember that one? Ln of 5. The trick to the question is that this is log base e of 5. Ln means log base e. And in case you've forgotten, e is just a number. I'd like you to pull it up on your calculator. It's above the divide sign. You see the little e there? Just type in e and hit enter. It'll tell you what it is. E is not a variable. I know it's a letter. It's not a variable. E is kind of like pi. It's always a certain number. In this case, 2.718, good enough. You know it goes forever, but 2.718. It's important that you not think E's a variable, because it's not. It's a number just like pi. It just happens to have special properties in math. When you get to calculus, you're going to see those properties a lot clearer. All we're doing now is telling you E is a thing. E is 2.718. They get to tell you the punchline in calculus of why that's such a special number. Yes?
You ever encountered a question on a test or anything else
Mm-hmm.
say this use log 5, where it's been kind of tricky because number is small or kind of inserted improperly?
We are not going to try to fool you on if that means base 5 or regular 5. We won't try to fool you. In fact, if there's ever a question about that, you can ask me, Mr. Server, is that supposed to be the base or is that supposed to be the argument? I'll tell you. Okay, so in this case, if I wrote it like that, you'd say it doesn't appear to be any base, and therefore Base is what? 10. We're not going to try to confuse you on that. All right. But if you saw something like this, you have to take my advice, which was the key to the question is the missing base. So the first thing you do is rewrite it so it doesn't have a missing base. Log base what? Of e to the 5th. And now, doesn't it become obvious? These are the same, and therefore the answer is 5. But looking at this one, you can't just see the answer is 5. All right, so whenever there's a missing base, that's the key. That's the trick to the question. All right, a few more patterns. I want you to noodle on that one for a while. Do whatever you think you could do to solve it. I'm going to pause for a moment while you use your noodle. All right, and I suspect some of you cheated and used your calculator, and the calculator said, what? Error. And if the calculator is saying error, it must not work. Here's another way to think of it. 1 to the x equals 2. And that seems like no big deal until you realize whatever you put in there, it's just multiplying 1 times itself over and over and over again. 1 to the 5th power is still 1. How's it ever going to be 2? It's not. And that's why you can't have a base of 1. That's one of the big rules in math, is that your logs cannot have bases of 1. And I'm going to give you the rules for these guys. If we use b for the base and a for the argument, would you assume that makes logical variables, right? What are the rules then for a? Simple for a has to be bigger than 0. A little more complicated for b. What did I just tell you 2 seconds ago about b? B cannot be 1. And what else? B also has to be bigger than 0. If I never said it, it's true. Both of them have to be positive. That has to be positive, that has to be positive, and that can't be 1. Those are the rules. So how could that ever come up in a math question? We're not going to say, what are the rules? What we're going to say is, here's a problem. What's its domain? As in, what can it be? Here's the simplest of them all, and it probably wouldn't be this simple on a test, but there. What can, well, the 3 has to be a 3. It can't be anything else. So is the 3 okay, first of all? Yes. So then it's all about the x. So how about that argument x? What do you know about it? It has to be greater than 0. So this one would be really simple. The domain is x is greater than 0. How about now? What has to be bigger than 0? Just be careful. What has to be bigger than 0? X plus 3 has to be bigger than 0, and then you could solve it. X has to be bigger than negative 3. Okay. What if I said that? What's its domain? Well, all that needs to be what? Bigger than 0. Do you remember having a math test where you had questions like this? And I remember me saying that that kind of looked like the tip of a number line, which is kind of a hint. 12-minute warning. So if this is a number line, what are the 2 important spots? -9 and, no, +9 and, okay. And then these 2 spots, can it be 0? Is 0 going to be bigger than 0? No, so it can't be those spots. And then you have to test the intervals. See what I'm saying? So on this one, the domain of it isn't so easy, but it's whatever makes this bigger than 0. And then you have to solve this little problem. And let's just try one. What's something big like 10? 10 goes in here, and it would be a positive times a positive, which is a positive. And is that bigger than 0? Yeah, it worked. Get the idea? You test intervals, and you see where it works and where it doesn't. Bottom line is, I'm pretty sure it doesn't work in here. I'll check it quick. I put in 0, and then I get a negative. Is a negative bigger than 0? No. It doesn't work in there. Probably works out here. A big negative number makes them both negative. That makes it negative times a negative makes positive is bigger than 0. It works. So there we go. So there's my intervals, negative infinity to negative 3, union with 9 to infinity. That's the domain of that one. All right, I've taught you everything that you need to know. Now let's look at your homework together. We're going to cut it down a bit because it's a little bit too large. This page, they are all easy enough and all so important. Remember me saying the most important thing is can you rewrite them? That's all just rewriting. Let me show you how. We're going to do that whole page. This is not a log yet, so you make it a log. What should the base be? Well, it's whatever the base is here, and that's 5. Then you jump around to the other side. Over to here, 1 over 125, and then back, negative 3. Did I just rewrite that as a log? Yes. And so I'm done. That's it. A lot of people think you have to like solve it somehow. No, it's just a true statement. If you thought about it, you could say, actually, that 1 over 125 could be a 5 to the negative third, exactly. And that's why it's actually a true statement. But you don't have to do all of that or think through all of that. You just have to rewrite them. Let's move on to number 8. That's the kind where you have to rewrite it the other way. That one starts as a log. Can you, sir, rewrite that for me? All right, 5 to the second equals 25. Did what he give me have a log in it? No, that's a good thing because it started as a log. So if it starts as a log, you want to put it in the other form that doesn't have a log. It's called exponential form. Exponential equations. All right, so this page is assigned. This next page is a little too long, so you can chop off the whole second column. They are things like this. Log base 3 of 27. Boy, that'd be a lot easier if they'd have said log base 3 of 3 to the third, because that is 27, and now the bases are the same. So what's the answer? 3. If the bases are the same, the answer's already there. Number 19. Would have been a lot nicer, Sam. They'd have written them with both having a base of 6. Can you do it? 6 to the what would make 1 over 36. Yes, there's a negative involved, but it's not negative 6. Negative 2 is correct. You know what just happened there? 6 to the negative 1 would have been 1/6. 6 squared is 36. You want both things. First you square it, then you flip it. It turns into 1/36. And why is it smart? Because now the base is the same, so the answer is right there. Negative 2. This one you do want the answer. You don't want to just rewrite them. All right. Once you get in a roll on these, they're super easy. No, you can't just use a calculator, because I get you could type these all into a calculator, but that also means you don't get the practice of rewriting that you really need. Remember me saying that the only thing that would be hard about problems that don't have a base, the answer has to do with that base. See, this one has no base. As soon as you have a base, then you go, oh, so you're saying, Mr. Server, make that as 10 to a power. Because once you realize there's no base, it's all about the base. Just as Megan Trainor always told us. Okay, this page, you're going to be skipping this and this and this. Now look back at the one we're actually doing here. Do I have to worry about that 7 causing a problem for my domain? Is 7 ever a problem? Base of 7? That's okay. So what do I have to worry about? I have to worry about this ever being negative. So I set it 4x plus 8. What? Greater than 0. That one's going to be super simple. No intervals to test or anything. This one's going to have the intervals because if you can factor it, you should. And then you set that greater than 0, and that has intervals. It's a good review for you. This one has no base. It would be really smart to, first thing you do, write it with a base. ln is the same as log base e. But people get all twisted in that and thinking that e is a variable. Remember, it's not. E's always going to be 2.718, and therefore you don't have to worry about that. That's not going to crash your function. What could crash it is if this part, anyway, you take it from there. That's all I have for you for today.